I'm letting him in. Hello, hello. Hello, hello. Welcome, everybody. As you are logging in here, please let us know what city and country you're logging in from or zooming in from, as well as what you're studying on Codecademy. Uh, Also, bonus points. If you attended the part one and part two, uh, please let us know. So again, let us know what city and country you are zooming in from, as well as whether or not you attended the part one and part two and what you're studying in Codecademy. We'd love to get to know you a little bit more. So we will get started in 1 minute here as people are logging on. Let's see here. We got Mumbai in the house. I did part one and two. So Nick, you got a disciple.
I
Smith is one
love
of your
that.
disciples here. All right. Mumbai,
Welcome
India
back.
in the house. Anybody else? We got, let's see here, Christopher Mack. We got uh, Joshua Joseph, two first names. Don't know if I can trust you. Sean Newman, Mitch Shaw. Uh, let us know what city and country you're zooming in from, as well as what you're studying on Codecademy, and if you attended part one and part two. Jacksonville, Florida. Oh yeah, biggest city by landmass. That's what's up. I made the last two. Look at you got some followers, Nick. Got some followers.
Can you hear me
Okay.
okay?
Yes, I can hear you.
All right,
We
my
can hear
network
you.
my network actually just dropped.
Oh no, that's perfect timing. Could not be better. Okay, well, we will get started right now. This session will be recorded and uploaded to YouTube, so there's gonna be a lot of information disseminated here. If you're like, I can't remember anything, you can watch it later. So, if you're wondering who is talking here, I'm Jonathan Trung. I'm the head of community at Codecademy. Welcome to the third and final part of Git Foundations, led by our esteemed Boston Club captain, Nick Edwards. No, you do not need to be in Boston in order to attend this event. Um, and last call out again, please let us know where you're zooming in from. We love meeting people from all around the world. In this workshop, you'll learn the following: viewing commit history, modifying commit history, stashing and cleanup, and best practices. About our guest speaker, as I mentioned before, Nick is he's in Boston and he's interested in how things work through the software development from end to end, and loves helping other people, which is one of the reasons why he's here. So. Enough of me talking. I'll pass it off to Nick. Nick, please take it away.
Thank you, Jonathan, and welcome everybody. Thanks for joining again today. If you were here for the first couple of sessions, thanks for returning. If you've been just joining for the first time, thank you for joining. You can find the recordings to the first session and the second session on Codecademy's YouTube sites. So yeah, as Jonathan mentioned, today we're going to talk a little bit more about Git, about viewing commit history, modifying the commit history via different operations. We've got a lot of things to cover today, so I'll cut the intro short there and let's get started. If you've been a part of my previous sessions, you've obviously seen the slide before. I always include it. I think it's very important to call these things out. Number one, be brave, be vulnerable, ask those questions. If you have any questions, don't think it's a silly question. You don't know what you don't know. We're all trying to learn every single day. We're trying to learn something new every day. So please, if you have a question, feel free to ask it. Be mindful and be respectful. Again, kind of goes into those questions. If somebody asks a question and you think it might be silly, no need to share that. That's totally fine. This is an environment that welcomes everybody. And get engaged. You guys are engaged just by showing up today. I appreciate that. And of course, let's try to have some fun while we're learning as well, right? And anytime we do a demo, if you guys have heard of the demo gods before, sometimes whenever we try to do a demo, we might run into bugs, we might run into errors, and they can be frustrating, especially when you're trying to show something live to people. So hopefully they're smiling upon us as we move forward. So just a quick recap of today's agenda. We're going to be doing some viewing and understanding commit history. We're going to look into creating and modifying commit history. We're going to talk a little bit about resetting. We're going to talk about stashing, and then we're going to have a quick discussion on some suggested best practices. So jumping right into viewing and understanding commit history, we've got 3 different commands that we're going to talk about here for a little bit, okay? So the first command on the left is git log. Git log, what is this? It shows the commit history for the current branch and its ancestors as well. So, anytime we create a branch, we're usually creating that branch from some kind of shared branch or other lower branch. And so, as we create those branches, they kind of form an ancestry, if you will. So when we use Git log, we're able to see all the commit history within the branch that we're currently on, as long as it's ancestors. It's useful for seeing who changed what and when. And anytime that we're viewing commits within the history, there's going to be a few things that are included in Git logs. We're going to see the commit hash. If you remember from the last session, the commit hash is essentially a unique identifier that identifies that commit and all of its metadata. Metadata being, the person that created the commit, the author, the date, when was that commit actually made. And then when we provide a commit, we usually provide a helpful message as well that kind of identifies what those changes entail. The next command we're going to take a look at is git show. I don't use this one a lot myself, but I thought it was important to share. So git show shows all the information and metadata for a specific commit. If you don't provide a commit hash, so when I say provide a commit hash, you have git show, and then right after show, you would put a space, and you would actually provide that commit hash for a specific commit. If you don't provide that, it's just going to show you the data for the latest commit that you've made. If you want to see information for a specific commit, you just need to provide the commit hash for that commit, and you'd be able to see that information. So yeah, as I just said, the latest commit is shown by default. And if you want to see a specific commit, you just need to provide the hash for it to do so. The next one we're going to take a look at is git diff. So this is going to show a line-by-line differences between your working and your staging area. It's going to show some differences between committed versus not committed. You can see differences between specific commits. You can see differences between specific branches, and you can see differences for a specific file. Moving to the next slide real quick, these are some of the additional arguments that you can include for those commands rather. I don't use git show a lot, but for git log and git diff, there are quite a few different arguments that you can include. And this is not an exhaustive list. I do want to point that out. There's a lot of different arguments that you can use in these commands. And so I would definitely encourage you to research those, take a look online. If you use AI, maybe, have a discussion with ChatGPT or Copilot or something to learn a little bit more about the different arguments. But these are some of the ones that I really wanted to call out. When you're using git log, again, we kind of pointed out that when you use git log, it only shows you the commits for the branch that you're on, as well as its ancestors. If you want to see the commits for like all the different branches that you have created at that moment in time, maybe you're working with like a main branch and a few different feature branches that have different code in it. You can include this --all flag. Flag, argument, they're kind of synonymous terms here. That's going to show you all the commits across all the different branches that you have within your repository. If you've ever used GitLog before, you might be able to remember that sometimes it takes up a lot of space in your command line, and so multiple rows are used to represent one commit, and it becomes a really long list. Sometimes this one line argument, you can use that as well to kind of make the commit history a little bit more condensed. And we're going to see some of this in practice when we move on to the hands-on demo portions of this event later. Graph is another argument that you can use. That's that third one right here. Graph is something that kind of provides an in-text visual, if you will, to see which branches were branched off of which. You can kind of think of it like a tree, if you will. Like, okay, you start with a main branch and then you branch off into a feature branch. There's going to be a line that actually shows that branch happening. And then let's say later on, you take all the changes that you put in that feature branch and you try to merge them back into your main branch. You're going to see one line diverting off of main, and you would see another line kind of going back into main. So you can kind of visualize where the branches branched off from each other and where they actually joined up later on as well. And then stat is something that's a little useful to kind of show how many lines were added, how many lines were removed, which files were impacted by this commit. It kind of shows you some statistics. So that's stat for short. About that specific commit. So those are some of the arguments. And again, we'll see some of those in action later in the event. But I just want to share them at a time here. Provides. So if you include like a staged flag, I believe that one shows you the differences between what's in area versus what's in your area. Cached is one that shows you the differences between what's committed versus what hasn't been committed, or whatever the latest changes within the branch are. Commit hash and If you provide one commit hash and then you do a space and you provide another commit hash, that one's going to show you the differences between two specific commits. And then if you do a branch, dot dot branch, and of course you would replace these commit hashes with a hash, or you replace branch with main, and then this would be feature branch or something. You don't want to include the brackets, leave the brackets off. Usually we use brackets just to show that, hey, this is like a variable. This is something that you need to replace when you use this command. So if you did main dot dot feature branch, that would show you the differences between those two specific branches. And then last but not least, if you wanted to see the differences made on a specific file, you could use git diff dash dash space and then provide the file name. So maybe it's index HTML or style CSS or something. You can see the specific changes that might be relevant to that specific file. All right, so this is going to take a lot of time. So that's why I wanted to kind of push forward to this one, because this is where we're going to be getting some hands-on. We're going to be talking about merging, squashing, rebasing, and cherry picks. I'm probably going to be on this section for a majority of the event because I really want to spend some time making sure that everyone understands the differences between the four of these, some use cases where we might want to use them and whatnot. And as we do this, we're going to be using some of those log commands to see what that commit history looks like. I do want to point out one thing real quick, and I'm going to actually share, I'm going to share a link to this. We're not going to do this on the event live, but I do want to share this project with you guys. This is in my personal GitHub. It's called Git Workshop, so just look for that repository on my GitHub. This is a workshop that we did in the Boston Club. It kind of dives a little bit deeper into rebasing, merging, squashing, and cherry picking, and it provides some step-by-step instructions that you can follow to create a rock, paper, scissors application. Everybody's pretty familiar with what rock, paper, scissors is. So what this is it's just like a very simple, web application that simulates that game. However, as you do the rebasing or merging or squashing, especially cherry picking, what the instructions will do is it'll actually bring you through all those motions and it'll help you visualize the commit history. That way you can understand what's happening behind the scenes. And then as you make those operations, you can actually see the game change in real time as well. So it's pretty interesting. I think it was really neat. We had a lot of fun with it. So I wanted to bring it to this event and just share it with everybody as well. Let me just get that URL for you guys here. My copy paste game is not that good right now, apparently. You know what? Let's just copy here, and then we'll do this one. All right, that's in the chat there if you guys can see that. And again, we're not going to be following these instructions per se, but I wanted to include it just in case if you guys wanted to check it out on your own after. Okay, so let's talk about merging. What is merging? Branches can be merged together if they share a common commit, and that commit is known as the merge base, if you will. There's a few different types of merges that can happen. A fast forward merge happens when the branch that you're merging into is an ancestor of the branch being merged. So let's think about that conceptually for a moment. In today's demo, we're going to have two branches. We're going to keep things super simple rather. We're going to start with a main branch. The main branch, if you're aware, sometimes in the past it might have been called the master branch. The main branch is where pretty much like your production environment lives. That's the code where your end users are going to be interacting. That branch usually it stays pretty static, right? We don't want to make any changes directly in main. We want to branch off of main or develop or any other shared branch that you might have if you're working in a team setting. You want to branch off of that branch. That way, if you were part of the previous sessions, if you don't know what a branch is pretty much an isolated environment within your code base, if you will. When you branch off of main, you're able to make changes within that separate branch without impacting the code in main or the functionality in main. And that's super important, especially if you have a live application that end users are using. You don't want to make any changes there that might, bring the program completely down, just make it completely unusable. You don't want to introduce some kind of poor end user experience for somebody who, they may have clicked a button before and it did X, Y, and Z, but now when they click that button, it only does X and then Y fails or something, right? You want to leave that code alone. And so we need to branch off of those branches before we start making changes. And then we can merge those branches back. So when I say a fast forward merge happens when a branch that you're merging into is an ancestor of the branch being merged. Imagine that you start off in main, right? You have maybe one commit in there. Let's say you move into a feature branch, you make a couple of changes in feature branch. The feature branch, or the main branch rather, is an ancestor of the feature branch. And so when we make changes in feature branch, we can merge those changes back into main without introducing any new commits. The commit hashes stay the same. We're pretty much just fast forwarding, and that'll make a little bit more sense when you actually see it happen. The other side of this is a recursive merge. That occurs when both branches have diverged from their merge base. So let's go back to our main feature branch example. Let's say you start off in main and you branch off into your feature branch and you start doing some work. If you're on a team, a development team, or you're doing some peer programming with other individuals on Code Academy or whatnot, right? The changes that are in main might have changed since you branched off a feature branch. So I'll use Jonathan as an example here. Let's say Jonathan and I are on the same team and we're working in the same code base. If I branch off a feature branch and I start doing some coding, or if I branch off of main into a feature branch and I start doing some coding, and then Jonathan pushes some changes to main, those changes that are now in main were not there when I branched off of main, if that makes sense, right? So as far as my local repository is concerned, there's changes in main that do not exist as far as I'm aware. And so if I try to merge my feature branch back into main, what Git is going to say, it's going to say, whoa, you're trying to push back into main, but there's been some things that have happened in main since you branched off last that are not they're not present within the branch that you're trying to merge back into. And so you might have some conflicts there that you need to get around. When this happens, it's totally fine. It's totally okay. But there's a new commit, creates new commit. There's a new commit that gets introduced to the commit history. And what that commit does is essentially says, okay, we know that these two branches shared a common commit at some point in time. What's changed between the two of them since then? What are the conflicts that have occurred, if any? We need to resolve those conflicts. And then once we go through that process, what Git's going to do is it's going to take those two and it's going to tie a knot around them, if you will. And by tying the knot there, we're connecting the two branches back together via a merge commit. And that's known as a recursive merge. And we're going to see that here in practice just now. So what I'm going to do is I'm going to talk about one concept. We're going to do a quick demo of it, and then I'm going to jump back into the presentation and we'll move on to the next concept. So I'm going to move over to my VS Code now. I'm going to change directories into my Git workshop folder. Let's make sure I spell that correctly. All right. So the first thing I'm going to do is right now, I don't have a repository at all established here. So I'm going to do git init just so we can get a repository. We have an empty Git repository now. It's perfect. I'm going to do git branch just to see what branch I'm on. I should be on main by default, although I might need to check that out first. So let's just switch to main. I might need to create it. All right, so now we're on main. So if I do git branch, well, should be on main. Let's get a file in here. Let's start there. So new file, we're just going to start with a README. I'm going to keep things super simple here. So I'm going to say, welcome to the event, just as like a first header for the README. Hopefully everybody can see that. I'll zoom in a little bit. Maybe that helps. If you can't see or if you're having a hard time seeing that, please just throw something in the chat and I will zoom in a little bit further, but hopefully this works. I'm going to clear my screen here just real quick. Okay, so if I do, let's say, git status. All right, we have a README file. It's red right now, which means it's not being tracked. We need to get that included. If you recall from previous sessions, what we can do, there's a couple of different ways we can do this. We can do git add README, or we can do git add dot. If you do a git add dot, it'll add all the changes across all the files that you currently have unstaged. Given the fact that we're only working with one file here and we're keeping things really simple, I'm just going to use git add dot just because it's less to type. If I do a git status again, we can see that that new file is now being tracked, which is great. So let's go ahead and throw a commit in there. So we're going to do git commit, and I'm just going to keep my commit messages pretty simple for the sake of the event. So we'll do just initial commit. Okay. So now if I do git log, again, we talked about that just a moment ago. Here we can see that we have this commit hash into point current branch. So anytime you see the head and then the pointer, that just tells you which branch you're actively on and which commit that one's on. It's usually going to be your latest one. The author, you can see the name, if you can see their email as well, and then you can see the date of the commit, and then you can see the message of the commit. So let's use one of those flags that I talked about earlier. Let's do git log one line. See the difference between these. So here you can see that we have a shortened commit hash. We still have that head pointer pointing to main, and then it just has our message, but you can see it's a lot less verbose. It may not look big or that impactful at this, or that significant rather at this moment in time, but you can imagine that if you had a ton of different commits, let's say you got like several dozen commits in a code base, scrolling through multiple lines of commits versus just multiple one lines of commits could be, that could be a little bit easier on the eyes or for your particular use case. And so sometimes it's really helpful if you're working in a large code base to use that flag. So going back to merging, right now we're on our main branch, right? We have one commit here. What I'm going to do is we're going to talk about a fast forward merge real quick. And again, that's when we don't have to introduce any new commits to do a merge. So we're on main right now. What I'm going to do is I'm going to switch over to a new branch. So we'll do git switch -c. You could also do git checkout -b. That's another way to do it. And then I'm just going to call this one feature branch. All right, so we're on the feature branch, and I can validate that just by doing git branch. You can see that we have main and we're on feature branch. That's one that's highlighted with the asterisk next to it. So let's make a couple of changes here. Let's say we're going to be welcome to the event. This is our first feature commit. So let's go ahead and save that. And what I'm going to do here, just to show again real quick, if I do a git status, we can see that we have a change. If I do git add all, and then I do a git commit -m, we'll say first feature commit, keep it simple. Okay, so now if I do a git log, you can see that we have feature branch. It's got the first feature branch. You can see that the head pointer is now moved. We're on feature branch and we're on this commit currently. And then we have the main branch right here. If we had other branches here, let's say you just created feature branch, but before creating feature branch, you had feature branch 1, feature branch 2, feature branch 3. Those other feature branches would not show up in this log. If you had other branches that had other commits in them, all you would need to do is git log -- all. This command right here, I'm not going to punch it in because I don't have any other branches created currently, but if you put this in, if you want to practice this on your own time when you're watching the recording or something, create a few different branches off of main and make some changes within them, and then just do a git log all. You'll be able to see all of the different commits that you've added across all those branches, not just the branch that you're currently in, if you have a use case for that, but I just want to call that out here. So let's go ahead and add one more commit. I'm just going to keep it simple. For the sake of time, we're going to use Copilot here as our trusty assistant to save some time there as well. So we've got our second feature commit in there. It's just a simple statement. If I do git status again, we'll see that it's got a change. It's been modified. So we'll do a git add dot to add that change. And then we'll do just type it out. We'll do a git commit again, -m. This will be our second feature commit. Okay. So if I do a git log again, we'll see that we have main, the initial commit, then we have our first feature commit, and then our second feature commit. So let's do a fast forward merge. Let's see what that looks like. I do want to call out, just take a mental note of what some of these hashes look like. We're going to take a look at them again in a second, and we're going to see if they change or not. So if I git switch back to main, if I do a git log here, see how the head pointer points to main, but the only commit that I see is initial commit? That's because I didn't include that all flag. So this is actually a good time to use that flag so you can see what it does. If we do git log -- all, now we can see that the head pointer is pointing to main. However, there's this other branch called feature branch that exists. We're not pointing to it right now, but it does have a first feature commit and a second feature commit. If I want to take those changes and move them into main to do a fast forward merge, all I need to do is git merge feature branch. And what that's going to do is you can see it says fast forward. We have README, we've got a few additions. And so if I go to git log again, okay, so we're pointing, but feature branch is also on this commit, right? Main, it was on this commit, and these other two commits existed in feature branch, but they were not a part of main just yet. After doing the fast forward merge, we can see that now we're up to date. Main and feature branch have all the same commits. Everything's completely synchronized. We're good to go, right? So that's a happy path. So just moving back to the presentation real quick. Again, we just did a fast forward merge. We're going to talk about a recursive example here. So here's where I'm going to in main that doesn't exist in feature branch just yet. Okay. And so that's to simulate that example that I was kind of talking about with Jonathan and I. Let's say that the change that I'm about to make is Jonathan adding something to main before I branch out to feature branch. So if I'm in main right now, let's say I go make a change. We have fast forward to feature branch as well. I'm not sure how that's going to impact us here, but let's figure it out. Let's try a recursive merge. So I'm going to go ahead and save that. And do git add all. Before I do that, I'm just going to validate that I'm still in main. I am. So git add dot git commit dash m. Let's say this is our third commit to main. Okay. So if I do a git log, we can see that head's still pointing to main. We have this new third commit to main. Feature branch is still back here. That's fine. What I'm going to actually do here is I'm going to create a new branch. I'm going to do git switch create feature branch, and then we'll just give it 2 just to make it different. If I do a git log dash dash all, we can see that main and feature branch 2 are on the same commit. So right now we're starting from the same point without in the timeline, the commit history timeline, if you will. We're starting from the same point. If I add one single change, so this merge will cause conflict. Okay. So if I do that and I do git status, just to make sure that we have a change there, we do git add, git commit dash m. And we'll say this is the 4th commit. Let's keep that simple. To feature branch 2. We'll add that. Let's do one more git log. So we can see that we're pointing to feature branch 2. We have this new commit here. Main's still on that one. That's totally fine. I'm going to switch back to main now. If I did the merge right now, we would have another fast forward merge, right? But what we're going to do first, before we do that, is we're going to add a new line. And we're going to say, this will also cause a conflict, and we're going to save that. Okay. Now let's try the the command that we did earlier. So if we do git merge feature branch 2, try to have everything spelled right there appropriately. So before I do this, actually, let me back up because I don't know, we added a new commit, correct? Did we? I don't actually recall doing that step. I don't think we did. So let's actually do that real quick. Oh, maybe we did add it. Let's see, git commit dash m 4th feature. The content of the file is newer. Sure. Save. All right. I think I was just getting an error down there that I didn't happen to notice. So if I do a git status now, we should have a change. We do. Perfect. Okay. So let's get that commit in there. Apologies. It's the demo gods I was telling you about. And then we'll say, I think this is our 5th commit overall. 5th commit to main. If I do a git log now. Okay, so we can see that we're on main. Main has a new commit that did not exist in the feature branch 2. So if you guys recall, before we created feature branch 2, we were starting from the same synchronized point in the timeline. We branched off into feature branch 2. We made a commit over there, and then we came back into main, but we made a change in main that does not exist in feature branch 2. So presumably, if we do git merge feature branch 2, we should get a merge conflict. We do. We can see that we have auto merging readme conflict, the content of merge conflict and readme, automatic merge failed, fix conflicts, and then commit the result. But I don't see my conflicts popping up. I think we're right. I wonder if I overwrite when I did the override earlier, if that kind of screwed me up here. If I try to do this again, you can see that we're currently in one. We need to change that. Okay. So let's go ahead and assume. I'm a little confused here, I'll be honest, because usually what happens is we'll have some kind of interactive editor come up and you'll see that, hey, you've got one change for one branch coming in, it's usually your incoming change, and then you have a current change as well, and you have an opportunity to either, you basically need to come in here and you need to clean up the file. You need to show, okay, I want this line here, or I don't want this line here rather. And then once you make those changes and you resolve the conflict, you can save the file. And when you save the file, all you need to do is you need to re-add it to your staging area. So if I did git add readme, what that's going to do is it's going to, after you resolve that conflict, it's going to add it back to your staging area. And then we can do a commit from here. So if I do, I think it's git merge -- continue. Perfect. Okay. So after you do that conflict resolution and you add that file back to your staging area, again, apologies, I'm not sure why it didn't pop up here. I think it had something to do with me overwriting the change down there. Maybe that's the wrong step that I should have taken. I'll have to look at that after when I watch the recording myself. However, we are on the same path that we would have been previously had we had that pop up. Once you do the conflict resolution, you add it back to your staging area. What you're going to do is going to do git merge -- continue. What that's going to tell the code editor here is says, hey, I've resolved those conflicts. I've saved the file. I've added it back to my staging area. We need to tie these two branches together with a single commit now. And so this is what's going to happen up here. It's going to open this up. It's going to give you an opportunity to change the name of the commit. Whatever you type here is what the message. So when you do a commit, you got that -m flag, and then you have the quotes. This is what you can essentially assume would be a part of that quote whenever you're doing that commit. So type whatever you would like here. I'm just going to leave it by default. And then when you close out, what that's going to do is it's going to say, okay, we've tied the commits together. If I do a git log now, you can now see that we have this merge branch, feature branch 2. And so that's the new commit. So if I go back to my presentation, when I say we do a recursive merge, again, the feature branch 2 and the main branch, they diverged from each other, right? Main had some changes in it that weren't in the feature branch. Feature branch 2 had some changes that weren't in the main branch. And so we've diverged. We don't have really a common base anymore. We do, but there's differences on each side of the house. And so what we need to do is we need to go through that conflict resolution process. We need to save those changes after we fix them. We need to add that file back to our staging area. And then when we do that merge -- continue, that tells the editor that says, hey, the resolution's all set. It's saved. We're ready to make that new commit. And that's that new commit that gets created here that you see here for the merge branch feature 2. Okay. So that's merging. Let's move on to rebasing now. So what is rebasing? Rebasing allows you to move or replay a set of commits onto a new base commit. This is commonly used to keep a clean, linear commit history. So what am I talking about here? Um, so let's focus on that word replay for a moment. Let's say we have our main branch, right? If we have our main branch and then we make some changes within feature branch. If you guys remember those commit hashes, right? Those things that identify those different commits. If you have main branch and then you go into feature branch and you add 3 commits or so, they're all going to have their own individual hashes. If for some reason there's gonna be the similar thing here where let's bring up Jonathan and I again. If Jonathan adds some changes to main that are not in the branch that I created previously, we're gonna have that conflict again, right? If we do a rebase, what that's going to do is it's going to notice that there's a change in main, but it's not going to care so much about it because what it's going to do is it's going to take all the commits that we have within our other feature branch and it's going to replay them on top of the main branch, on top of that latest commit that Jonathan added. This is good in some ways because it's when I say it keeps a more clean linear commit history, if you guys remember when we had that recursive merge example, we had that new commit get introduced. That commit doesn't really have a lot of value to it, right? Because it doesn't really represent any specific changes. It just represents the fact that the 2 branches diverged and we had to merge them and tie them back together via some kind of conflict resolution. But there really isn't a lot of specific changes that were included within that specific commit. And depending on who you ask, I think it's a larger conversation within the development community. Some people like rebasing, some people don't. Some people like merging, some people don't. I think it's very important to just kind of stick to a standard whenever you're working with a team, and make sure that everybody's working within the same way. The problem with rebasing that some people argue, and I get it, I understand, it it rewrites the commit hash. So when I say replay, we're going back to that word here, we're taking all those commits that existed in the feature branch and we're replaying them on top of main. But when I say we're replaying them, the timestamp and like the message, all that remains the same, but the commit hash changes because it's actually a different commit. What Git is doing is it's taking those other commits and it's creating a new commit on top of main that represents that change, but the hash changes. This is not so much of a problem when you're working within like your own individual branch and you're going into a shared branch. It becomes a huge problem if you're rebasing one shared branch onto like another shared branch because what that can do, some of the problems you might run into there. Let's say if Jonathan has a copy of the code base, let's say there's like a shared develop branch. So when I say like a shared branch, typically the pattern that I'm most accustomed to working is you have that main branch, which is where the production environment lies. From main, you step down one level and you go to a stage branch. A stage branch is a branch that essentially mimics the main production branch, but it's its own independent branch. A lot of people will push changes to stage when they're getting ready for a deployment. And so you can think if you have 5 developers on one team, all 5 of those developers might be pushing all of their changes for the next release to this shared stage branch. That shared stage branch is great to do some integration testing to make sure all those changes that we're pushing to that shared branch, they're all compatible and they're all working together. And then you can take that one branch and you can merge it into main whenever you do your release, instead of having a bunch of different branches merging into main and conflicts and whatnot coming up. So that's what a stage branch is. And then there's one layer below the stage branch, and that's the develop branch. So develop branch is where developers will usually push their changes to get them tested. And so your develop branch might have like a similar environment. Let's say it's like a cloud environment. If you push changes to a develop branch, those changes might get pushed up to a cloud environment within a container somewhere that you can, then maybe you introduce a new API endpoint and you want to do some testing, right? But you want to test it in an environment that mimics your real production environment. That's what a develop branch is for. You can push changes to there. You can test them there. If they don't work, you can continue making changes there. If they do work and you're ready to move them up, you can push them up to stage. But when I say shared branch, that's kind of what I'm referring to here. All right, so enough of the talking and rebasing. Let's get into a quick example of this. I'm going to clear my screen. And apologies if I'm moving a little bit quick. There's a lot of content that I want to cover in this session, and we do have the recording. I'm also in the Boston Club. I'm pretty active in the Code Academy community. So if you have questions, by all means, please feel free to reach out to me there. Join the club. You don't need to be in Boston to join the club. We welcome everybody. We've got people from all over the world there. But come in, start a conversation, ask some questions, and we can keep refining that knowledge together. All right, so I'm going to clear my screen here. Let's get started with the rebasing example. So if I do, let's see what branch I'm on. Git branch main. Okay. We're on main right now. So what I'm going to do is I'm going to, let's see, how do we want to go about doing this? I think we need to make some, we need some changes to exist in both right now. Let's start with a new file. Just to keep things a little bit independent of each other. Maybe that'll help the understanding as well. So if I just do a make directory rebase example, and then I go into my rebase example directory and I start a new repository. Is it just me, or is I should have a new directory popped in over here? Let me jump over to Git bash. Rebase example.
While you're trying to figure things out, Nick, if there are any
Yep.
questions, please let us know in the chat. We want to make this more of like a discussion in addition to like a workshop. So if you have any questions, feel free to ask Nick directly.
I've even created a file in here and it's still not popping in. Interesting. Go ahead and reload my window and see what that does. Oh, there it is. Okay. We're back in track. So yeah, that's actually a good call out too. I'll just share that real quick. If you do Control-Shift-P, if you're on Windows, it might be the same for Mac, I'm not sure. Control-Shift-P will pull up your command palette. If something's ever acting wonky or weird in your IDE, VS Code in particular, as I'm using here, if you do developer reload window, that'll actually just refresh the environment. So if something isn't working quite right, as you guys just saw, you can do that, and hopefully the issue you were having will solve itself. So let's open up README here, and let's add, again, that welcome to the event message. We'll save that. We'll do a git add all. I'm going to avoid the statuses just for the sake of time here. But as you guys can see, I'm making changes and saving them. If I do a git commit -m, how are we doing on time right now, Jonathan, by the way, while I type this out?
We have about 18 minutes left.
Oof. We might need a session 4 if I'm being honest.
All good. All good.
Okay.
That'll
All
help
right.
break up the content too if we do it apart.
Okay. All right. I don't think we're going to get to the rest of the content in time. Okay, so we've got our initial commit there. If I do a git log to show that, we can see that we have the initial commit. Great. So let's go off into a new branch now. So I'm going to do git. Oh, I need to quit out of my logs first. Okay. Oh, maybe I was already. Git switch -c to create. We're just going to name this one feature. Just keep things simple. And then now that we're in the feature branch, let's go ahead and do. We'll do a second header. It says rebase example. We're going to save that. We're going to do git add all. I'm going to do git commit -m. First commit for rebase. All right, so we've got one example in there, and then say the commit hashes are going to change. If I had $1 for every time I write N before A and change, I would be rich. For some reason, that's one of the most common typos I make. We're going to add that change here. We're going to do git commit -m, and we'll do second commit on added a rebase statement. Okay. If I do git log, okay, so let's take a look here. I don't want to rush through this. It's just for the sake of time, because this is an important concept to really drill into. We have
Nick,
that in,
we do have a question. Can you git add, commit, and push in one line?
you can. There is, I'll answer that one real quick. If you wanted to add and do a message at the same time, let's say if I go, you know, real quick, we'll just do that. So instead of doing git add and then git commit, what we can do is we can do git, I believe it is commit -am, and then say third commit. I believe this is going to work. -a is that kind of like that all that dot, if you will, the git add dot, or add rather. And then you have your M here as well for the merge message. So if I do that, you can see that we not only added the change, but we also made the commit at the same time. You can chain multiple commands together as well. I believe you could do something like git add dot and then git commit -m. You could do something like that as well to chain multiple commands together. I believe that would work too. But the -am is a pretty nifty way of doing that. It's a great question. Thanks for bringing that up. Okay, so now that that's been added, if we do the git log one more time, just to get the commit history back in here again. So I want us to pay attention to these 3 commit hashes. So this one's going to stay the same. This is our main commit, right? But this commit hash for the first commit, this commit hash for the second commit, and then this commit hash for the third commit. When I say replay, remember we talked about the rebasing, we're rewriting these commits on top of main. These commit hashes are going to actually change. And so in order for that to happen, what we need to do is we need to go back to main really quick. Git switch main. You can see that we actually lose some of the work that we did in there. Just to be expected. This, let's say, let's rebase now. Save that. I'm going to use that -am, add change to main. Okay, so if I do a git log --all, need to add one more L there. Okay, so we can see that we had main here. This is where main started. We branched off of the feature, which has these 3 commits currently. Well, feature technically has this commit as well, because that's where we branched from. But now the head's pointing to main, and yep, there it is. You see, I tell you, I mistype it all the time. We have this new commit hash that's in main. This change does not exist in the feature branch, right? It's not there. So let's see what happens when we do git merge. Actually, you know what I'm going to do just for the sake of keeping things a little more simple? I'm going to clear the screen. We're going to do a git log one more time so that we can see that information. I need to do an all so we can see all of it. Okay. So now what I'm going to do is I'm going to do git rebase. There's that rebase keyword. And I'm going to type in the branch that I want to rebase onto main. So if I do rebase feature. So remember earlier when I was a little confused, right? And I was like, kind of like, why didn't this, current change or incoming change, that kind of stuff pop up? This is what I was expecting to see earlier. And again, I think it had something to do with me doing that overwrite there. So what we can do here is we can either accept the current change. The current change is the changes that we currently have within this file. The incoming changes are the changes that are going to be trying to be merged into the README file here. I don't want to get rid of any of the code. I want to keep both of the code, or I want to keep the code from both the branches rather. So what I'm going to do is I'm just going to accept both changes because I don't want to get rid of anything. I want to keep everything that I've typed here so far. So by accepting both changes, and I can save that. What I can do now is I can git add readme. Those files are there. And now that we've done the rebase, what I can do is I can do git rebase -- continue. Same thing as merge, except this time it's a rebase operation we're doing. So I'm going to continue that. It's going to open up the editor. And then here's where I can actually change the message. So I'll type it correctly this time. Git changes to main. I'm going to save that, and then I'm going to close. Okay, so we've done the rebase now. If I do git log, let's take a look at first commit for rebase. This one right here. Let's see, it's C438822. If I go back up. Let's see, where did I go wrong? Let's see, we added a new commit. Interesting. I must have messed something up. I must have missed a step because I'm trying to rush through this stuff. All right, let's try one more time. Git merge. I'm just going to get us synced up here. Git switch to feature 2. Oh, wait. That branch doesn't exist, so we need to create it. Okay. Let's add one quick change. Let's try again. Save that. Git add. Git commit. Commit hash should change. Okay. And then if I go back into, just do a git log, dash all, so I can see that main's currently here. Feature 2 has this change in there. Okay. So if I go back over to main, and let's say I take all this out. Say welcome to the event. Instead of adding something, let's remove something here. Make sure we have a change there that's saved. It is git add git commit -m remove code. Okay. I think I know where I went wrong because now that I'm thinking about this, I think I stayed in main and that's not what I wanted to do. The reason for that is because I can explain this. So yes, that's exactly what happened. Because I stayed in main the last time and I did the rebase, main had a new commit in it, but main was also aware of all of the changes that were in feature branch. And so it didn't get confused. It knew of all the things that were there. And so it kind of essentially, when you did the rebase, rebasing and merging are very similar behind the scenes in a lot of ways. Because I had knowledge of all the different changes, it was able to kind of resolve them and move through all that rather easily, if you will. And so I think what it did is it actually just kind of like it did a fast forward and it moved some of the code from feature in. I think what I wanted to do is I want to switch. We're in main right now, but what I want to do is I want to actually switch back into the feature that I had. So if I go back to feature, what was it, feature 2? Yes. So if I switch back into feature 2, all that code is still there, right? If I do a git rebase now, so I'm going to do git rebase main because I want to rebase on top of main. And actually, what I'm going to do real quick because I forgot to pull up the logs again so we can see what happens. So I'm going to do rebase -- abort. So if you ever do this type of operation and you want to back up because you forgot something, you can do -- abort, and I'll just cancel the operation altogether. The reason I wanted to do that is again because I want to demonstrate how the commit hash might change. So if we do git log, if I scroll up, so feature 2 right here, feature 2 has this commit hash should change. We already added this one to main, that's fine. This commit hash right here. So C7, I'm going to actually take that and I'm going to paste it in here so we can keep a record of it. Into the chat there. Okay, so now that we've done that, I'm going to clear the screen. Let's do the rebase now. We're still in feature 2. We are. So git rebase main. So what I'm telling it now, what this command is going to do, it's going to say, I want to take the current branch that I'm on right now, and I want to rebase onto main. So when I do this, here again, we're going to get those changes in here. The current change is that the code's not there. We removed it from main. Feature branch says that we have some incoming changes that are going to be going into main. We want to accept both changes just to keep everything there. I'm going to save it. I do need to add it as well.
Nick, not to interrupt, but we have about
Yep.
5 minutes left before we need to wrap
Okay.
things up.
So we'll wrap up the rebase example. We'll end there, and then Jonathan, you and I can get together. We'll put a 4th session together. In the 4th session, we'll go over cherry picking, squashing, and then we'll talk more about the stashing and the resets. Squashing and cherry picking should be easier to go through and include the stashing and switching as well, resetting rather. So let's just wrap up with the rebase example, and then we'll call it quits there and have a 4th session in a couple of weeks.
All right, sounds good.
Okay, so where were we? We've added the README. Okay, we need to finish the rebase. So if I do git rebase dash 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 continue. Okay, commit hash should change. It's going to, I click out of this, we're going to save that. Perfect. Okay. So if I go back over to main and I do git merge feature 2. Okay. So commit hashes are going to change. All that code that we just had in feature 2 is here now. However, if I clear the screen and I do a git log, so commit hash should change. This is the most recent commit that we added, right? But we did a rebase. And so if I take this commit hash and I paste it back into here, and I take that previous one, those are the 2 commit hashes we have now. See how they're different? That's a really key point to understand about rebasing. When you rebase, you do run the risk. Again, if there's conflicts that occur, or if you've got code in one branch that you're rebasing onto that doesn't exist in the branch that you're rebasing from, you're going to run into a conflict resolution. And when you resolve that conflict and you do that fast forward merge, those commit hashes are going to change. That's not a big deal. If we go back to that concept of shared branches, if you're in that develop branch, that lowermost environment where you're doing your testing with other people, and you branch off of develop into feature branch or something, right? If you add some changes there, to rebase on top of develop, that's okay, because the code that was in develop, the commit hashes that are in develop, those are going to remain intact. They're going to remain the same. But the commits that were in your feature branch, the hashes of those are going to change when they get replayed on top of develop. And that's okay, because from develop to stage to main, that commit history is going to remain intact. Those hashes aren't going to change. However, if for whatever reason you find yourself in a situation where you're deciding to rebase develop or something, if you're coding directly in develop and then you go rebase on top of stage or something, you run the risk of changing the commit history between those shared branches, and then everyone else's project of that particular branch, if they have that repository stored locally, it's going to get massively confused, because it's going to say, wait, okay, we've had this branch that we share. However, the commit history in that branch on the remote repository is different from the commit history that I have in this current repository in my local copy. And then it gets really squirrely from there. And so that's a really key point to kind of highlight and think about when you're doing rebasing, is that you run the risk of those commit hashes changing. And if you're working within shared branches and you're changing commit history within a shared branch, you run the risk of impacting everyone else's workflow. And that just introduces waste into your overall workflow. And it's a big mess. It's a headache. You got to take time to clean it up. And the time that it takes to clean that up and fix that is time away from doing your development work, doing that innovative work that's helping your product grow or helping your company grow, or things of that nature. And so you always want to be mindful about the things that you're doing, how they're going to impact the commit history, how they're going to impact other people within the same code base. And again, if you create a standard and you stick to that, and everyone sticks to that and agrees to it, you should be all set. But again, rebasing, that's just something you really want to watch out for. And so apologies we weren't able to get through all the content. It seems to be a theme with myself. I try to put a lot of stuff in, and then I spend too much time talking about certain concepts. It's really just because I want everyone to understand. And of course, we ran into a couple of issues today too, so that didn't help. So apologies for that. Hopefully you guys still learned a few things. And then, yeah, maybe in a week or two, whenever Jonathan and I can get something scheduled, we'll have a next event.
Well, Nick, thank you so much for taking the time to put this presentation slash workshop together. I'm sure that People found it very, very helpful. Already we have, again, I like to say, a few disciples of yours following along who attended the first and second part. And so I am sure that they will attend the fourth. Again, if you're wondering where you can find this recording, give us about a week for us to upload it onto YouTube. And if you have any questions, feel free, and I'm speaking for you, Nick, but feel free to reach out to Nick directly
Yes,
in our
please.
community. So that's it for now. I hope everyone has a great rest of the week. Talk to you later. Bye.
Enjoy.